in these notes, because there's no way to fit, this much instruction, a week's worth of instruction for Algebra 2 into a very short lesson. So what I did was I boiled everything down, provided a few key examples, and we're going to go through those. We're going to do some examples from your homework too. We're going to get out the book and do some homework problems. But I also have a PowerPoint in my locker, and I'm going to show you guys how to go in and get that. It's the same instructions that are on the back of your policy page. So you go into the locker, go to task 5, which is this week's task, and you can watch a PowerPoint, and that's on parallel and perpendicular lines, because there was no way to get that, all of that into a short lesson without skipping some important stuff. So you've got the PowerPoint. Also, I put up here that you should go watch Slope Dude. You just Google Slope Dude on YouTube for a reminder about negative, positive, zero, and undefined slopes. It's a way, the thing I love about that video, I found it when I was teaching Algebra 2 at Foothill, the students remembered it. And it gave them some little key phrases to help them remember slope. So I advise going to watch it. It's very silly, but it's effective. So do that, and that's on your notes. You might want to highlight that or something so you remember to go back and watch it. Now, we're going to go over some definitions. Most of this is review. A few things are new. This slope. This is probably the formula you remember for slope, and this is derived from our point slope form. If you just divide both sides by x2 minus x1, you get this. Okay, so that you can see that our slope formula ties in beautifully with our point slope form. And you should be used to this. This is rise over run, right? Does that ring a bell? Okay. So, because it's the distance, we move in the y direction over the distance we move in the x direction. Now, another way of calculating slope is to use our standard form, and we're going to go over the different forms in a minute. But if you take the standard form and put it into slope-intercept form, the slope m will be negative a over b. Maybe I'll do that really quickly. So if I want to isolate y. I want to get y all by itself on the left. So I'm solving for y equals negative ax plus c. So I just subtracted ax from both sides. Now I'm going to divide by b. So y equals negative a over b times x plus c over b. So this becomes our slope, and this is our y-intercept. So if you have this form, you can look at your coefficients for your x and your y, and you can see what the slope is from those. Okay, so that's another quick way to get slope if you don't have 2 points. All right. So that's just a refresher. We're going to use that when we go over the couple of problems that I have at the end, which I'm hoping I'll have time to get to. Okay, so this is a review. This should absolutely, everything here you should have seen in Algebra 1, but it's been a long time since Algebra 1. It was second semester Algebra 1, but I know that it's been a while. So this is point slope form. So you're going to use this form when you're given 2 points, and you have a whole section on this in the homework, when you're given a graph with 2 points identified, or a point and a slope. So point slope, that's your clue when it's a good time to use point slope form. M is the slope, and x1, y1 is a point on the line. Okay? And you need to remember to keep your negative signs straight. We're going to do an example. And then slope-intercept form. This is where we learned to solve for y back in Algebra 1. Get y on the left all by itself. And have the x term come first, because then we can identify our slope, which is m, and the y-intercept. So you want to use this when you're given a slope and a y-intercept. We're also going to talk about the most efficient way to graph each form. And this one, usually what you do is you'll start with one of these and then convert it to this one. Okay? So a lot of your homework and probably some of your test and your worksheet says write the equation in standard form, and they'll give you maybe a point and a slope. So you start out in this form and then convert it to that form. And we're going to do some examples of that right now. Okay, so we have a point, so you should be writing this down, and we have a slope. So we're going to use point-slope form. And we're going to write the equation for the line, then we're going to convert it to each of the other forms. So you see that it's very easy to go from one form to the other. Okay, so we have our point, and there's our formula. So we have y minus y1. Okay, so our point is 2, or y, in our ordered pair. This is x, this is y, it's always in alphabetical order. So y minus 2 equals 2/5 is the slope. I'm using that formula times x. Now, x1 is negative. It's -7, and I'm subtracting it. So it's x plus 7. This should ring a bell from Algebra 1. Okay, so I plugged in my point, remembering to switch my signs, and then I put in my slope. So I'm done with putting it in point-slope form. This is my point-slope form column. Now, I want to convert it to slope-intercept form. So I need it in y equals mx plus b form. Well, a minimum, I'm going to have to do the distributive property here. So that gives me y minus 2, go ahead and sign in and take a lesson, equals 2/5 x plus 14/5. Okay, because it's 2/5 times 7. Okay, but it's not quite there because we still have a 2 over here. So I need to add the 2 to both sides. So I've got then y equals 2/5 x plus 14/5 plus, well, 2 is the same as 10 over 5. I'm going to make it fifths so that I can add these together. So then y equals 2/5 x plus 24 over 5. And I'm in slope-intercept form. I've got my slope of 2/5 and my y-intercept is 24/5, which is 4 4/5. All right.
That's your answer?
Well, this is slope-intercept form for the same line. So these are the same line, but I converted from point-slope form to slope-intercept form. And now I'm going to put it in standard form, because often on your homework, that's what you're going to have to do. You're going to be given some information, and you're going to say, write an equation for a line in standard form. And so you're going to start out with one of these, depending on the information you're given, and you're going to convert it to standard form. Okay, if that's what it says, you have to read the directions very carefully, because it'll tell you what form they want it in. If they don't specify a form, I often put it in this form or that form, so I don't have to go through this last conversion. But if they say standard form, it needs to be an ax plus by equals c form. Well, that's pretty easy to get to from here. We've got this. If I subtract this x from both sides, this x term, I'll have negative 2/5 x plus y equals 24/5. I'm not done though, because a, b, and c have to be integers. And depending on who you ask, most texts say that this needs to be a positive integer, the one in front of x. So not everybody says that. So I'm going to multiply everything by 5. That's going to clear out my denominators so I have integers. So let's do that first. So I'd have negative 2x plus 5y equals 24. So I just multiplied every single term by 5. Now I really want this, I want this to be positive. I'd probably get this right on a test, but some teachers would mark it wrong, okay? So again, it depends on which textbook you're using. So I'm going to multiply this whole equation by -1, or divide, either way. 2x minus 5y equals -24. These are equivalent equations. So this is in standard form. we have 2 points. What do I need in order to fill in all the information on this formula? What do I need to calculate?
Find the slope.
Slope. And I have 2 points, so I can use my slope formula, y2 minus y1 over x2 minus x1. M equals. Now, here's the trick. It doesn't matter which of these are x1 and which are x2. I could have reversed that. Okay? But I've got 2 points. It doesn't matter which is which. What matters is that if you're subtracting this from that, then you have to subtract this from that. Because if you switch the direction, your sign's going to change. And you won't have the right slope. So, let's fill this in. I like writing the letters here because it helps me fill this in. So you have 8 minus negative 2, so that's plus 2, over 8, because that's x2, minus x1, which is 3. Now, very common mistake is to put the x's on top and the y's on the bottom. Okay, so just really watch you need to make sure you're subtracting in the same direction, both in the numerator and the denominator, and get your x's, your run, this is your rise, in the denominator. So this is 10 over 5, so the slope is just 2. So our slope is 2. Now, here's the other thing. We've got a point, we've got 2 points, and we know we have a slope too. So I can pick either one of these points for my formula. So I could say for my y1, if it's negative 2, y minus y1 is y plus 2 equals, here's my slope, 2 times x minus x1. Okay, so that's one formula. Now the other one that's also correct is I could just use these 2 8s as my formula, as my points. So y minus 8 equals 2 times x minus 8. Now if you go and use the distributive property, it doesn't matter which one of these you use, believe it or not, you'll end up with the same line there. Okay, those are the same thing. So now, I can pick one of these to put in slope-intercept form. So I'll just pick this one. So I need to use the distributive property, so I have y plus 2 equals 2x minus 6. So I distributed my 2. Now I need to get y all by itself on the left. I'm solving for y. So I'm going to subtract 2 from both sides. So that is the same line, but in slope-intercept form. Do you believe me that this will give you the same one, or do you want me to show you? You believe me? Because you've done this in Algebra 1. Okay. And then, to get this in standard form, I need to move my x term over here. So, I've got negative 2x plus y equals negative 8. I don't like that negative, so I'm going to say 2x minus y equals positive 8. I don't need to put a plus sign. Equals 8. Okay? Because I'm just multiplying every single term by negative 1, which I